Continuing on in section 8.8 here. Now, a rectangular prism has a volume of 60x cubed plus 34x squared plus 4x. What expression can also represent the dimensions of the prism using factoring? So here, guys, again, we're going to want to check for a greatest common factor. 60 is 6 times 10, 2 times 3, and 2 times 5. So here I have 2 times 2 times 3 times 5. And I have 3 x's, x cubed. 34 is 2 times 17, and 17 is prime. So 2 times 17 and 2 x's. 4 is 2 times 2 times x. So if we look here, our greatest common factor is 2x. We multiply by what's left. Here, 30 x squared plus 17x, remember each row is its own term, plus 2. And we want to try and break that down further if we can. We already took out our greatest common factor, so now we're going to try our swing method. Multiply by 30. X squared plus 17x plus 60. We want to multiply to 60 and add to 17. Since we're adding, our signs are the same. They match the middle, positive. Here we're going to use 12 and 5. So 12 and 5. Don't forget, though, that we still have to undo that swing. So since we multiplied by 30, now we're going to divide by 30. Reduce our fractions if we can. 2 over 5 and 1 over 6. Swing our denominators, and we get 5x plus 2 and 6x plus 1. Don't forget again that greatest common factor of 2x. So here are dimensions. One of them is 2x, another is 5x plus 2, and another 6x plus 1. If we multiply those all together again, we get back to where we started. Take note on page 531 summarizes all the things we've done as far as factoring polynomials. It's our steps. Step 1, don't panic. That's always our first step. Okay, don't panic. Evaluate the information we have and figure out what we can do from there. So here it tells us we're going to factor out our greatest common factor. Always do that before we go to any of the next steps. We check. If the polynomial has 2 or 3 terms, we look for the difference of 2 squares. That's like a squared minus b squared, or x squared minus 4, for example. A perfect square trinomial, something like x squared plus 2xy plus y squared, or x squared plus 6x plus 9, where x squared is a perfect square, 9 is a perfect square, 3 squared. We multiply them together, 3x, and double it. Or a pair of binomial factors. And that's anytime we find something that multiplies to our last number and either adds or subtracts to our middle. If the polynomial has 4 or more terms, we're going to group terms and factor by grouping to find a common binomial factor. And then the last thing we always want to do is make sure there's no common factors other than 1. We never want to leave a factor like 2x plus 4, for example. We can always take out the common 2 and go x plus 2. So we always want to double check to make sure there's no common factors. And then to double check as well, we can always FOIL it back to make sure we get to our original answer. Quick recap here for section 8.8. Some polynomials of a degree greater than 2 can be factored. If a polynomial has 4 or more terms, it may be possible to group the terms and factor binomials from the groups. This process is called factoring by grouping. And that's all I have for section 8.8.